All right, this is a progressive philosophy of education by Ryan DeHaan. Let's just jump right into it. So the purpose of education is providing the tools, structure, and social skills and knowledge to prepare student lives for success that benefits the individual as well as society. Every student learns differently, which requires educators to be able to identify and introduce those tools to meet their student needs. Also, education provides structure, which prepares students for time management and stress management needed for the workplace. Also provides social skills that are crucial for proper mental development and coping skills when corresponding with peers. Also, it provides knowledge, which is the foundation for the growth and development of the student's future endeavors and will be a determining factor in the success. So let's move right on to teacher role. The teacher role is a guide for the students through the content, and it's their responsibility to find the best path for each student. The teacher will be knowledgeable enough to adjust and adapt their methods of teaching to best suit the student. The teacher must present the content in a relatable and interesting fashion while simultaneously informing the students as to why the material is important. And also, the teacher is always a role model for knowledge acquisition, professional conduct, emotional intelligence, and social justice. So the role of the student is students should approach learning as an opportunity for growth and should be ready and willing to learn ideally. Students will be required to collaborate with their peers and learn from each other. Students will require perseverance for when situations become more difficult. So my subject is science, which can include biology, anatomy, chemistry, or life science. As my teacher I'm observing says, the more subjects you could teach, the better, but most likely life science or biology. So let's move on to why I teach adolescents. I provided a short video, which is basically science educators discussing why it's important to understand why adolescents, when they're growing up, that they have an underdeveloped frontal cortex, which has to do with inhibitions of their impulses. And so it's important for not only parents but also instructors to realize like these types of behaviors is not necessarily something they're choosing to do, and knowing where it comes from is important so you can react accordingly. Also, that it treats these students as the young adults they are and just tell them what's going on with their body so they can understand it. Also, be receptive to the fact that they could be suffering from other issues with depression or anxiety. And so it really has to do with just understanding where the students are at mentally in a developmental stage, which I find very important. All right, so also we're going to go to these are young adults. This is content related. I prefer to teach content on a more mature level because I enjoy engaging with the students, I like the back and forth. It keeps things fresh and new. Each class is different. Every student's going to have a different opinion. And so if the student can engage in the content, it keeps it fresh for me, and it keeps it fresh for them. Also, the biological development. Adolescent students are going through many changes, ranging from biological to academic, and I want to be part of that guiding process before they're subjected to the realities of adulthood. I think my limited training in psychology and empathy would be better serving these students during these crucial and developmental years. Lastly, the challenge. Due to these life-altering changes, these students are considered difficult to handle. I think I have the proper mannerisms and wit that is required to keep the content and myself relatable in order to continue to facilitate the learning process. All right, moving on to my goals. So to expose and inspire the wonders of the natural world and scientific discovery, to provide the basic framework of the scientific method and how to use it, to bridge the gap of the science and the layman and inspire a new generation of scientifically curious people based on critical thinking and skepticism. And I have my quote here by Louis Pasteur. It says, "Science knows no country because knowledge belongs to humanity and is the torch that illuminates the world." I strongly agree with that. I think science is one of the few things that really brings us together. And let's move on to creating a progressive classroom. So first we have creating a new curriculum based on modern applicable scientific discoveries and articles, because science is always changing. Utilizing technology to better facilitate the acquisition of new changes and provide immediate access to knowledge. Encourage students to challenge the content and question until they understand, and to focus more on labs and experiments opposed to handouts, and provide students with a timely feedback to better assess their focus. Let's move on to curriculum. So providing students a connection to expository science texts will help instill the importance and application of the content. And that's one thing that science can't escape, is the fact that we can't escape expository texts. And so Providing a student a method of either relation or real-life consequence will draw the content from the text and enrich their other modalities with technological media options and hands-on experimentation. Different current event articles from biology, life science, chemistry, and anatomy may also provide a guided method of maintaining skepticism, which will further enable their ability to properly navigate the internet. So kind of a double win there. You know, if you teach them how to be critical and skeptic and have skeptic minds, they'll be less susceptible to the fake news online. So instructional strategies, definitely technology. You know, students cannot avoid the advancement of technology in all areas, including education. Access to the internet will provide students with richer media options for absorbing the science content. So here's some examples: virtual labs, streaming videos, online classrooms, international resources, virtual reality, podcasting, augmented reality. Virtual reality and augmented reality have not been implemented in an official capacity that I know of, but I have plans. Instruction strategies. This is for high-level thinking with expository texts. It is the focus to develop the methods of how these science students think and absorb the expository information. So here's reasoning by metaphor and analogy. Students will come up with creative ways to explain the content in their own words to simplify the concepts for the other students, as well as to demonstrate their own understanding. And there's a quote from Einstein here: "If you cannot explain it simply, you do not understand it well enough." Also, another example would be flowcharts. By clearly writing down the sequence of events, the student reduction with confusion is eliminated when cause and effect relationships are made explicit and visible, which encourages reasoning and clarity. And the jigsaw one, which I swear I was going to use this before I saw the example: students will be separated into groups of 4, where each will be responsible for taking their section notes. After, they will each present their section to other group members to complete the notes. This helps with attention and understanding of expository text. This also helps with chunking, because there's a lot of information in science expository text, so this is chunking out for the students for their note-taking. It also helps with as students teach their sections, because they have to be experts on it, and it helps with memory retention when you actually teach the information. And lastly, for assessments. So we have entry-level daily journal entries of the content-related question. We have a mnemonic science song that's content-related as well, so hopefully it gets stuck in their head. Also, for progress monitoring, we have the corner note-taking with questions, so the questions hopefully will be available for the students who are too shy to ask in class, and they can write down the question and ask me later. Socratic guided questions during the lecture, so try to keep the lecture more engaged, so I'm not just talking to them, but I'm actually having a conversation with them, asking them questions and guiding them to the answers. Also, discover mistakes. The teacher made an encyclopedia page, this has to do with technology, where I would intentionally make an encyclopedia page with mistakes in it, and after the content that students would have to find those mistakes. Anticipation guides, which is accessing prior knowledge, and online grade tracking, so this has to go back with timely feedback so that students constantly know what their score is, so there's no surprises. For summative, there'll be participation points, observational assessment, and monitoring. This has to do with the scaffolding, depending on how I see the students advance for specific situations. Projects and experiments, and then fill-in and matching tests. Also, I was trying to avoid the high-risk test taking, so all these assignments will be relatively the same, some weighted more than the other, but there won't be any one single thing that's going to totally sink a student. Any student who happens to make a mistake, they can find their way out with a little bit of hard work. And so, oops. So hopefully, with the combination of technology and some progressive classroom, we can try to avoid some of the expository text problems and help create a richer learning environment with more technology and hands-on assignments.